So in this video, we're going to talk about adding rational expressions.
We're going to start with fractions like you're used to seeing them, such as 3/4 plus 2/4. When you add those, you'll get 5/4. Check to see if it can be reduced. If it can't, then that's your answer. You can leave it as an improper fraction. Again, common denominators. We have x/4 plus 3/4. Since the denominator is the same, you add the numerators, x plus 3/4. They're not like terms. You can't combine them, and it's reduced because you can't factor anything out. Here, if we have a denominator that has a variable in it, it doesn't matter. It's a common denominator, so you add the numerators. Look for like terms. Here we have 5 plus x plus 2. Since 5 and 2 are both constants, we can combine those and we'll get 7 plus x over x. Since that's a group, it can't be divided out. It's not a factor. Now you can actually see it, kind of. Let's take a look at x squared plus 3 over 2x. Again, remember your main thing is to get common denominators. So if we add that with x squared plus 1, as long as 2x is the denominator, you keep that. It stays the same, and you just combine the numerators. Again, you're looking for like terms. So I'll get 2x squared because the coefficients are 1. My constants are 3 and 1, so I get 4. Here I can actually factor out a 2. You can't really see that very well. We'll do it again.
Now you can see it. That's 2 times x squared plus 2 over 2x. I have common factors of 2 in numerator and denominator. That gives me 1 for each of those. So in the numerator I have x squared plus 2, in the denominator I have x. That's my answer.
Now let's take a look at uncommon denominators. For example, here we have 5 and 6 as our uncommon denominators. Remember that our goal is to find a common multiple between 5 and 6, and the lowest one is going to be 30. What do I have to multiply each of those denominators by? Well, I need to multiply the numerator by the same thing. So since I multiplied 5 and 6, then I have to multiply 5 on the top, and on the first fraction I have to multiply 6 on the top and the bottom. Since I get 18 and 10, when I combine those two, I get 28 over 30. Again, I'm looking to see if I can reduce the fraction. Here I can take out a 2 as a common factor. So I'm going to end up with 14 over 15. Again, common denominators. That's the theme now. Common denominators, common denominators. Here, between 2x and 3, the least common multiple is going to be 6x. I probably want to take a look at that as a separate one. What's missing? Well, in the first one, 3 is the only thing missing. In the second one, 2x is what's missing. So I have to multiply the same thing on top. This time, this is a group. 3 plus x is a group, so you have to distribute that 3 and watch what happens. I'll multiply by the first term and I'll get 9. Multiply by the second term and I get 3x. Over here there's only one term, so I only have to multiply the coefficients together and then add the exponents of the variables. Remember, that's the rule there. I have a common denominator now, so I do what I was doing before and just combine the numerators. 10x squared plus 3x plus 9. It's good to go ahead and write it in standard form because then you can figure out easily if it needs to be factored or not. Looking at this, I don't see a GCF, but I do need to know if it can be factored or not. So I'm going to go ahead and take a look at the first coefficient is 10. Factors are 5 and 2. First combination I'm going to try is 3 and 3, but when I do that, I get 29. If I make it -3 and -3, then it's just the opposite of that. I tried 9 and 1, and then 1 and 9 because those will give me different values. But here I can tell none of those values are going to work. They're all too high. So I'm going to check 10 and 1 to see if that will work. different combinations for 9, 3, and 3. Again, that will be 30 and 3. So it will either be positive 33 or negative 33. Neither of those are going to give me 3. 9 and 1. Again, that doesn't give me the right number either. It gives me 19. And if I look at 9 and 10, well, that starts out with 90. So that doesn't work either. So without going into the quadratic formula or anything else, this one won't factor, so this will be my answer. There's no GCF that can be taken out of the numerator and factored out of numerator and denominator. In this example, we're going to take a look at what happens when I have binomials in the denominators and I have to make the same denominator with a binomial. Again, I'm focusing on the denominator, x plus 2 and x minus 4. I don't know what those numbers are. So I have to multiply them together because I have to account for both numbers. So both of them will be factors in the denominator. So I just write them as two different factors. Sometimes it'll be helpful to multiply them out, but most of the time, not really. So I write this for both of them because I want to treat them separately. Because when I have to multiply by the missing factor, look at what that is on the top. X plus 3 is a group. So I'm going to have to use FOIL to multiply those out. When I do that, multiply my first terms. It'll be x squared. Multiply your outies and your innies. I'll add them together in a minute. Right now, negative 12. Now I'm going to have to FOIL on this side too. First terms, your outies and your innies. Again, we'll add them together later. So now I need to combine like terms. I have common denominators, so I can just combine the numerators. I really don't want to write all of that out or multiply those out, so I'll just take a look. Again, the coefficients of x squared, 1 and 2, so that gives me 3x squared. I really am just going to have to replace this. So that'll be negative x and 6x, so that gives me positive 5x, negative 12, and so that'll give me negative 8. Now I need to factor the trinomial that's the numerator. So now that I can see it, 3 times 1 will be the factors of the first coefficient. We get negative 8 with negative 4 and 2. That gives us a 2. That won't work. Other combinations for negative 8. Since the coefficients are different, I can try the other combination. If I just change the signs, it'll just be negative 2. This one, that one won't work either. So 8 and negative 1. This gives me negative 3 and 8, which gives me 5, and that's my middle coefficient. So this is my answer. This is my first set of parentheses, and this is my second set of parentheses. So my two factors will be 3x plus 8 and x minus 1 over x plus 2 times x minus 4. Now, none of these will divide out, so that means that this is my final answer. Some books will multiply them back out, but this is how you add rational expressions.